In today's class, we will discuss a complex DC circuit problem from Cambridge ES Physics, and this question is from March 2021. We will solve this question using different approaches, and that will help you to improve your understanding of DC circuits. First of all, let's try to understand what is given to us for this question. For this question, it is given that a cell of electromotive force E and negligible internal resistance, it simply means that R is equal to 0, means small r, is connected in the circuit, and the circuit is shown here. It is also given to us that the voltmeter has a very high resistance. It simply means that this is kind of ideal voltmeter. We can treat this voltmeter as an ideal voltmeter, and there is no current passing through this one because it has very high resistance. It is also given to us that voltmeter reads a potential difference, and that is equal to V out. It simply means that the reading on this voltmeter is equal to V out. And question is asking us, we need to find the ratio between V out and E. Now, how we can answer this? Let's try to understand more about this circuit. Let's say this point is point A, and this point is point B, and this is C, and this is D. You can also call junction A, junction B, junction C, and D. If we look at this point P, and this is connected with negative terminal of this cell, we can say potential at B, this is equal to 0 volt, because we are assuming that negative terminal is at 0 potential. Now, if we look at point A, then simply you can say that the potential at point A is equal to E, because this is directly connected with positive terminal of power supply, means in this case positive terminal of cell. So this terminal is positive and this one is negative terminal of this cell. Now let's move on to next concept. Now if I ask you what is potential at point C, you will also simply say potential at C is equal to 0 volt. Why? Because there is no resistor connected between B and C. Or you can simply say this is just an ideal wire. Now, the next thing what we need to understand is that let's try to connect a voltmeter. Let's say if we connect a voltmeter between A and B, let's say this is voltmeter 1. So the reading on this voltmeter 1 will be equal to E minus 0, simply is equal to E. Let's take another voltmeter and connect between A and C. So between A and C, let's say this is voltmeter V2, we can say this is voltmeter 2. And if you look at the potential at this point is 0 volt and potential at A is equal to E. So the reading on this voltmeter also is equal to E. So this is the first very basic concept you need to understand. The potential between means the potential difference between AB is equal to potential difference between AC. Let's try to redraw the circuit before we find the ratio between V out and E. So this is how we can redraw our circuit. Our voltmeter is connected across 4 ohm resistor, so we can connect our voltmeter here, and the reading on this voltmeter means the potential difference across this one is equal to V out. And this point is point A, as we have already labeled here. So this is point A, and this is point B, and this point is point D, as you can see here after 2 ohm resistor, and this point is point C. We have already discussed that the potential difference between A and C, you can also say at this point, and this point means the potential difference between this point, or between A and C is equal to E. So I will just connect another voltmeter here so you can see easily. So this is another voltmeter that is connected here, and that is connected between A and C, and the reading on this voltmeter is equal to E. Now if you look at this part of the circuit, you can see this is just like the potential divider circuit. Potential divider circuit, you no need to worry about this one, even you can ignore this. Now if you look at this point, let's say current I is coming, in this case current I is coming. So I will pass through 2 ohm resistor and also through 4 ohm resistor. But if we look at this circuit carefully now, EMF is across 6 ohm resistor, but V out is across 4 ohm resistor. But the same current is passing through these two resistor. We can simply say that the current passing through 4 ohm resistor is equal to the combined current passing through 2 ohm and plus 4 ohms. We can say 6 ohm resistor. This is 6 ohm. The voltage, the potential difference across 4 ohm resistor is equal to V out, and the resistance of this one is 4. And the potential difference across 6 ohm means across 2 and 4 ohm resistor, this is equal to E. So we can write down this is E. And the total resistance of 2 and 4, this is 6. Then simply you can find out the ratio between V out and E. So V out over E, this will be simply 4 by 6. This is equal to 2 by 3. So our final answer will be D. Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's class, we will solve a tricky question on potentiometer circuit using two different methods so you can have clear understanding about this type of concepts and also this type of questions. And this question is from October-November 2020. For this question, a typical potentiometer circuit is given and question is asking us what are the two readings of the voltmeter when the sliding contact, this sliding contact is connected at end P and when this is at end Q. This is what we need to answer. We simply need to find the readings on this voltmeter. First of all, let's try to label some points. As this point is P, we can say this point is R, and this point we can say S, and let's say this point is T. We will answer this question using two different methods. First of all, I will explain you using simple method, and later we will discuss one longer method to answer the same question. First of all, let's try to answer this one using very simple method. So for that purpose, we need to assume one point at zero potential. In this case, we will assume this point P is at zero potential. So I can say this is at zero potential, or simply you can also understand this is connected with ground. When something is connected at ground, its potential is zero. So we can simply write here the potential of this point is zero. Now the next thing we need to understand is that if the potential of this point is zero, what is the potential of this one? The potential of this one is also zero because it is just connected by an ideal wire. There is no gain or drop of potential. So we can simply say it also has the same potential. Now if we go to this point, you will also simply say that the potential of point R, this is also 0 volt because there is an ideal wire between these 2 points. If the positive terminal of the cell is at 0 potential, so the negative has to be at negative 3 volts. And if you look at the second cell, if the negative terminal of the cell is at 0 volt, so the positive has to be at plus 3 volts. So these are the basic things we need to understand. So I hope now you have understanding of these things now. Why we mark this one negative 3 volt, why we mark this one positive 3 volt. Positive terminal means that this is at higher potential as compared with negative terminal, and the negative terminal simply means that this is at lower potential as compared with positive terminal. So as you can see here, if the positive terminal here, this is at 0 volt, so the negative has to be at lower potential means negative 3 volt, and in this case negative is at 0, so the positive has to be at higher potential, means it has to be at plus 3 volts. So these are the basic things we have to understand. If these are clear to you, now answering this question is very straightforward. Let's try to find out voltmeter reading when sliding contact is at NP. First of all, when it is at NP. When sliding contact is at NP, as you can see here, when it is connected here, then the voltmeter reading is simply equal to the potential difference between point P and point S. So we can simply write down SP, or we can simply say this is equal to the potential at point P minus potential at point S. Potential at P is 0 volts, we can write here, and the potential at point S, this is equal to negative 3 volts, we can write down. So simply our final answer is 3 volts. Now let's try to find out voltmeter reading when sliding contact is at NQ. When it is at NQ, simply we need to find the potential difference between point S and point Q, and we understand the potential difference at point Q, this is equal to plus 3 volts. As you can see here, it is just connected by a wire with positive terminal of this cell. Now simply we can write down potential difference between S and Q, this is equal to VSQ, or we can say this is equal to potential at point Q minus potential at point S. So here is point S. Now at point Q we have the potential that is equal to plus 3 volts, then the potential at point S is negative 3 volts. So our final answer is plus 6 volts. So this is reading on voltmeter when sliding contact is connected to NQ. So our final answer is D. Now let's try to answer this question using our second method, or we can say second approach for this problem. And our second approach is based on Kirchhoff's second law, or we can simply say Kirchhoff voltage law, or you can say simply KVL. According to this law, for any loop delta V has to be equal to 0. And now in order to answer this question, we need to consider two different loops. First loop we will consider when the sliding contact is connected at NP, and the second loop we will consider when it is connected at NQ. First of all, let's consider when the sliding contact is connected at NP and try to find voltmeter reading. In this case, we will consider this loop. And in this loop, you can see the potential difference between P and T. We can say VPT, the potential difference between P and T, and the potential difference between T and S. We can write down this is TS, and the potential difference between S and P, we can say VSP. And this one has to be equal to 0. Potential difference between P and T, there is no potential difference. So this is 0 because there is just one ideal wire between these 2 points. So there is no voltage gain and voltage drop. And for TS, when we go from positive terminal to negative terminal, so the voltage drop is negative. Voltage drop means it's negative 3 volts. And for VSP, actually this is the reading on the voltmeter, so we don't know what is value of this. We can simply write down VSP, and this has to be equal to 0. From here we can find out value of VSP, mean the potential difference across voltmeter, and that is equal to 3 volts. So this is how we can find the reading on voltmeter when sliding contact is connected at NP. Now let's move on and try to find out what is voltmeter reading when this sliding contact this is connected at NQ. When sliding contact is connected at NQ, we can consider this loop. We can consider this loop here, and we can also go anti-clockwise. So as you can see here, we can go anti-clockwise. For this loop, you can see the potential difference between Q and R. We can say this is VQR plus the potential difference between R and T. We can write that VRT, and the potential difference between T and S, we can say this is plus VTS, and the last one between S and Q, we can say this is SQ. All has to be equal to 0 because we started from this point. If we come back to the same point, so the potential difference has to be equal to 0. Now what is the potential difference between Q and R? So in this case we are moving from positive terminal of the battery to negative terminal, so the potential drop, so we will write negative 3 volts. And when we go from point R to point T, there is only ideal wire, so it means there is no voltage gain and there is no voltage drop. So VRT means the potential difference between R and T, this is equal to 0. And when we go from T to S, we go from positive terminal to negative terminal. So in this case voltage drop, so this is negative 3 volts. And next one is VSQ, and this is the reading, this is the potential difference across this voltmeter. We don't know what is value of this, we can simply write down VSQ. So our final answer VSQ in this case is equal to plus 6 volts. So again our answer for this question is D. So this is how you can answer this question using two different methods. Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's class, we will discuss an important and tricky question on complex DC circuits. Why this question is important? Because this question is a great question to understand complex DC circuits. We will use a smart method to answer this kind of complex circuits. For this question, it is given to us that all the resistors are identical. Identical simply means that they have the same resistance, and all the ammeters, they have negligible resistance. It simply means that ammeters are ideal ammeters and they have no resistance. Question is also telling us that reading on ammeter 1, A1 is 0.6 amps, means reading on this ammeter, this is given, this is equal to 0.6 amps. Question is asking us what are the readings on the other ammeters, mean what is reading on A2, what is reading on A3, and what is reading on A4. This is what we need to find out. First of all, let's try to connect voltmeters across different branches. Let's say we have voltmeter V1 and we connect across this branch. So first across this branch. Let's say we have another voltmeter and the second voltmeter we connect across this branch here. And the third one, let's say we connect across the third branch and here. And the fourth one we connect across the fourth branch. Let's say this is voltmeter V4 and we connect across this branch. And this is the main idea you need to understand. If I look at V1, you can simply see here V1, and this is V2. You see, this is this point and this point, they are at the same potential because this wire is an ideal wire. So it means I'm finding the potential difference across this point and across this point. And for the second voltmeter, I'm finding the potential difference across this point and across this point. So the potential difference across these two branches is the same because this point is at the same potential as this one, and this point is a common point among these two voltmeters. So it means that V1 is equal to V2. So we can simply write down here V1 is equal to V2 because we are finding the potential difference between two same points for V1 and also V2. So we can say that V1 is equal to V2. Now let's look at this now. V3 now. If we look at this V2, this point and this point, they are at the same potential. And if we look at the second point, this point and this point, they're also at the same potential because one ideal wire between these 2 points. We can also connect like this. Let's say I connect this one to here, or I can extend this one to here. Result is the same. So it means that V2 is also equal to V3, and we can say it is also equal to V1. Now let's look at V4, reading on voltmeter 4 now. So this point and this point, they are at the same potential because there is an ideal wire between them. We can also connect like this. Let's say we connect to this point. And if we look at the second point for third voltmeter and fourth voltmeter is also the same. The first point is the same and the second point is also the same. It means that the reading on voltmeter 4 is also the same as reading on voltmeter 3. So here we can say that V1 is equal to V2 and this is equal to V3 and this is equal to V4. As the reading across each branch is the same, it simply means that all the branches are just connected in parallel. So this is just a parallel circuit. Let me redraw this one so you can get a clear picture of this circuit. I'm starting from this battery. So this is our battery. You can simply say this is a cell and we have ammeter A2 that is connected here. And after ammeter A2 we have ammeter A1, so we can connect ammeter A1 here. So this is our ammeter A1, and after ammeter A1 we have two resistors, so we can connect two resistors here. So these are two resistors connected in series, so they are connected in series. Then we have the third branch, and for the third branch we have ammeter A3 that is connected here, and we have one resistor that is connected in series with ammeter. So we can redraw this one like this. And the last one we have fourth ammeter, that one is A4, and this has three resistors connected in series, means 1, 2 and 3. So we can draw these three resistors in series. So here we can redraw these resistors here. So this is our circuit. So this is simple a parallel circuit. Now we need to find out the readings on A2, A3 and A4. Now let's say the resistance of each resistor, this is R, so simply we can write down here each resistor has the same resistance because they are identical resistors. Let's say current coming from the battery and passing through ammeter 2, let's say that current is I2, and current passing through ammeter 1 and through these two resistors, let's say that current is I1, and the reading of I1 is given as it is given here, that is equal to 0.6 amps. 0.6 amps. And let's say current passing through ammeter 3, this is I3, and current passing through ammeter 4, let's say this is I4, and also the same current is passing through these three resistors. First of all, look at V1, and V1 is equal to V3. So V1, if we look at V1, this is equal to 0.6, means current passing through this branch and its resistance, and let's say its resistance is 2R because we have said resistance of each resistor is R and these two resistors are connected in series, so the total resistance of this branch that is equal to 2R. And for V3 we can simply say this is I3. We don't know what is value of I3, but we know the resistance of this branch that is equal to R. Now from here we can cancel R because this is common, and we can find out I3 from here, and that is 2 times of I1, so simply is equal to 1.2 amps. So this is reading on ammeter 3 we can find out. Now let's try to find out reading on ammeter 4. Again we will compare with V1. V1 is also equal to V4, so we can again write down V1 is equal to V4, and V1 is equal to 0.6 times the resistance of this branch, that is equal to 2R. And current passing through emitter 4, this is I4, and the total resistance of this branch, this is equal to 3R. Now R is common, we can simply cancel. So I4 is simply equal to 1.2 divided by 3. So this is equal to 0.4 amps. So this is reading of I4. Now if we need to find out I2, so I2 simply equal to I1 plus I3 plus I4. So if we add all of them together, our final answer will be 2.2 amps. Now you can see I2 is 2.2 amps. So this is the right answer. D is the answer. And I3 is 1.2. So this is 1.2. I4 is 0.4. So this is 0.4. So our answer for this question is D. This is kind of typical question and very important question to understand complex DC circuits. First of all, let's try to understand what is given to us. For this question, if we read this question carefully, it is given to us that there are three identical lamps L1, L2 and L3. They are connected to a battery and battery has no internal resistance. What we need to find out, simply we need to compare the brightness of lamps L1 and L2 when the switch S is closed. Means simply when we close this switch, we need to compare the brightness of L1 and L2. Or simply we can say we simply need to compare the power. As we understand, power means the P here is for power, and the power is linked with brightness. Higher the power, brighter the bulb. And vice versa is also true. If the power is greater, brightness will be greater, and if the power is lower, brightness also will be lower. Let's try to answer this question now. So the first thing what I will do is I will redraw this circuit so you can get clear picture. Let me redraw first of all. As you can see here, I have already redrawn these two circuits. Means these two circuits, they are identical. If you look at circuit 1 and the second circuit and third circuit, they are identical circuit, but just shape is different, but circuit is the same. As you can see, the resistance is not given to us, so we can simply assume that resistance of this lamp, let's say, is R. So the resistance of this lamp and this lamp is also R. As you can see in question, it is given to you the lamp, first lamp, this is L1. We can also say that this is L1 and this is L2 and this lamp is L3. And also we can write down here L1, this is L2 and this is L3. Now let's try to calculate total resistance of the circuit. Now we need to calculate total resistance. We can simply say R total, this is equal to resistance of L1 plus resistance of, mean the total resistance of these two resistors. As you can see, these two resistors, they are connected in parallel. Means these are two lamps, so I simply said these are two resistors, so it's the same thing. A total resistance of these two lamps, this is equal to R by 2, so simply we can write down here. So the total resistance is equal to 3 by 2 R. Now let's try to calculate total current in the circuit. So I total simply is equal to EMF of this power supply. Let's say EMF of this power supply is equal to E. We can write down E divided by R total. R total we have already calculated, so we just need to divide EMF by R total. We can say this is 3R by 2, or we can simplify and we can write down this is 2E over 3R. So this is I total. Now let's say current coming from this power supply is I1, and at this point, means at this junction, current will split into two parts. Let's say I2 is passing through L2 and I3 is passing through L3. So we can say in this case I1 will be equal to I2 plus I3. But you also need to understand the total current is equal to I total, so I total is equal to I1. Now as these two lamps, they have the same resistance, we can also say that I2 is equal to I3. So then we can simply say that I1 is equal to 2 times of I2. So these are the main points we need to understand, and then we can calculate power of lamp 1 and we can also calculate power of lamp 2. Let's try to calculate P1 first. P1 means the power of lamp 1. In order to calculate P1 means the power of lamp 1, so we can simply say P1 is equal to I1 squared times R, and I1 is equal to I total, so we can simply say that this is equal to 2E divided by 3R multiplied by R. If we simplify this one, we will get this is 4E squared divided by 9R. So this is value of P1. Now let's try to calculate what is value of P2, means the power 2 we can calculate as I2. This is equal to I1 by 2. So simply we can say I2 is equal to 2E divided by 6R. So this is value of I2. Now we can calculate value of P2. P2 will be simply equal to I2 squared times R. As we understand, I2 is equal to 2E divided by 6R and square of this multiplied by R. If we simplify this one, we will get this is equal to 4E squared divided by 36 times R. So this is value of P2. So we have calculated P1 and we have also calculated P2. Now simply we need to compare these two values. First of all, let's try to calculate the ratio between P1 and P2, means P1 divided by P2. So if we divide P1 by P2, we can simply say that P1 is equal to 4E squared divided by 9R, and it is multiplied by 36R divided by 4E squared. So this is 4E squared. Simply we can cancel these two, and R we can cancel with R, and if we divide 36 by 9, we will get 4. So it simply means the ratio is equal to 4. Or we can say that P1 is equal to 4 times of P2. We can also simply say P1 is greater than P2. So this one is simply telling us that lamp 1 is brighter than lamp 2. So lamp 1 is brighter than lamp 2. So it means this is the right answer. B is our answer. So how many times L1 is brighter? L1 is 4 times brighter than L2. Now let me explain to you how to answer this type of questions in your final exam. Let's say this question is on your final exam and you need to answer this question. But in exam you have only around 1.5 minutes for each question. Means 1.5 minutes for one question. Time is very limited, so we need to be very quick to answer this type of questions. So if this question was on exam, so the simple way to answer this question is, as current coming from battery, let's say this is I1, and at this point this current will split into two parts, I2 and I3. So we can also write down, in this case I1 will be equal to I2 plus I3, and as these lamps are identical, means they have the same resistance, R2 is equal to R3, so we can say that I1 is equal to 2 times of I2. So simply you can say I1 is greater than I2. So R is the same, R1 is equal to R2. So then simply you can say P is directly proportional to I square, as we simply understand P is equal to I square times R. So we will say P1 is greater than P2. So simply you can find your final answer. But if they ask you how many times lamp 1 is brighter than lamp 2, then you have to use formula. You will simply say P1 is equal to I1 squared times R, and P2 is equal to I1 by 2 squared times R. Now if we solve this one, P2, what we will get? We will get this is I1 squared times R divided by 4. So this one is P2. P2 is equal to P1 by 4. It means P1 is equal to 4 times of P2. P1 is 4 times brighter than P2. So this is how you can answer in your exam. With enough practice, even you don't need to do any calculations and you can answer this type of questions. You just need practice. If your concepts are clear, these questions are just piece of cake. In today's class, we will talk about one complex DC circuit problem from Cambridge AS Physics. For this question, it is given to us that ammeter reading is 0. It simply means that there is no current passing through this ammeter. So this is what is given to us. And question is simply asking us, we need to find out the resistance of resistor R. So our resistor R is connected at this point. Now, as it is given to us that there is no current passing through this ammeter, it also simply means that potential at these 2 points is the same. Simply if we connect our voltmeter between these 2 points, the reading on this voltmeter, that will be equal to 0. Now let's label some points before we answer this question. Let's say this point is P and this point is Q, and let's say this point is R and this point is S, and this point is T and this point is, let's say this is U. First of all, let's try to find out direction of current. I will simply draw one possible direction of current and then I will ask you one simple question about that. Let's say current flow like this. Now my question for you is that, is it possible that current flow like this? Take some time and try to answer this question. Is it possible or not? Especially you need to look at current in this wire. Okay, let me explain to you now. If you look at this wire, you can simply see that current is flowing in two directions. Means current is flowing to the left and current is also flowing to the right at the same time in the same wire. It means current has two different directions. So is it possible? I hope simply you will say that not possible. So it simply means there is no current passing through this wire. As there is no current passing through this wire and also there is no current passing through this ammeter, so it simply means that these are two different circuits, or I can simply say that in this circuit current will flow like this. Current will flow like this, as you can see. So this is one circuit. We can treat this one as one separate circuit, and in this circuit current will flow like this. Current will flow like this. So this is another circuit. So we have two different circuits now. So here is one circuit and here is another circuit. Now, what is common between these two circuits? If we look at point P and if we look at point Q, this is over point Q and this is over point P, potential at these 2 points is the same. We can simply write down Vp, this is equal to Vq, and these 2 points, they are at zero potential. We can simply say is equal to 0 volt. Now, potential at point R is also equal to potential at point S. We can simply say VR is equal to Vs. Now, the next thing, the question is that how we can find out potential at point R. In order to find potential at point R, we can also simply write down that the potential at point R is equal to potential difference across this 100 ohm resistor. Across this 100 ohm resistor. Let me clean first of all. It simply means that potential at point R, this is equal to potential difference across 100 ohm resistor. It simply means that if we connect our voltmeter between these 2 points, meaning between P and R, the reading on this voltmeter will be equal to the potential at point R. Why this will be equal to potential at R? Because point P, this is at zero potential. So we can simply say potential at point R, that will be equal to potential difference across 100 ohm resistor. So we can simply say that that is equal to potential difference across 100 ohm resistor. So R is equal to 100 ohms. Now the question is that how we can find out the potential difference across 100 ohm resistor. So we can simply say this is our 100 ohm resistor. Now we need to find the potential difference across this one. As you can see in this circuit, we have only two resistors, and these two resistors, they are connected in series. So we can simply find out the potential difference across 100 ohm resistor by just dividing resistance of 100 ohm resistor by the total resistance of the circuit, mean this circuit. So the total resistance of this circuit in this case, that is equal to 50 plus 100. 50 plus 100, and we need to multiply by EMF of power supply, that is 12. So in this case, the potential difference across 100 ohm resistor, that simply will be equal to 8 volts, and this is the same as potential at point R. As the potential at this point R we have already found, means the potential at point R, that is equal to 8 volts. It also tells us that the potential at point S, that is also equal to 8 volts. As we know, the potential at point S now and the potential at point Q, that is equal to 0 volt. It simply means that if we connect our voltmeter across this 200 ohm resistor, the reading on this one, that will be equal to 8 volts. Now as you can see, the EMF of power supply, this is equal to 24 volts, and the potential difference across 200 ohm resistor, that is equal to 8 volts. So simply we can also say that if we connect our voltmeter between point P and point S, reading on this voltmeter, that will be equal to 16 volts. Now as you can see here, resistor R and 200 ohm resistor, they are connected in series. It means same current is passing through R and same current is passing through 200 ohm resistor, but the potential difference across R is double than potential difference across 200 ohm resistor. From here simply we can conclude that R is 2 times of 200. So it means the resistance of R is equal to 4 400 ohms. Or we can also simply find out in a different way. As you can see, current passing through 200 ohm. Let's say this is I1. We can say this is I1, and let's say current passing through this one, that is I2. But in this case, I1 is equal to I2. So simply we can say the potential difference across 200 ohm resistor means the V1 divided by its resistance, that has to be equal to the potential difference across resistor R divided by the resistance of R. Let's say that resistance is R2. R simply we can write down R is equal to 200. So V is 16. So we have to find value of R. So this is just simply you will find out that R is equal to 400 ohms, and that is over R. So our answer for this question is 400. In this video, we will explore more about complex DC circuits. We have four resistors and they are not identical resistors, mean their resistance is different. And a voltmeter is also connected in this circuit, and reading on this voltmeter is equal to 0, and this is very important point for us to answer this question. So what we need to find out, we simply need to find the equation for this setup. In order to answer this question, let's say this point is point A, and this point is B. This point is B. As it is given to us that reading on this voltmeter is 0, it simply means that the potential at point A is equal to potential at point B. Means the potential difference between point A and B is equal to 0. Simply this is what we can conclude from here. Now let's say current coming from this battery is I, and at this junction current I will split into two parts. Let's say I1 is passing through resistor P and I2 is passing through resistor R. As the potential at this point is the same, and potential at A is equal to potential at B, we can also conclude that if we attach one voltmeter, let's say voltmeter 1 across resistor P, and we attach another voltmeter across resistor R, so the reading on voltmeter V1 has to be equal to V2. Another way of writing this one is we can say I1 P has to be equal to I2R, and this is based on Ohm's law. Now we can rearrange this. We can say I1 over I2 has to be equal to R over P. Now let's move on to next resistor. Now next resistor is Q. The potential at this point are the same, and potential at this point is also same. So we can also attach another voltmeter across this resistor Q and another voltmeter across resistor S. From here we can also simply conclude that V3 has to be equal to V4. As you can see, there is no potential difference between A and B. It means the same current I1 is passing through Q and same current I2 is also passing through S. I2 means the same current through resistor R. So we can say I1 times Q is equal to I2 times S. From here we can rearrange, we can get I1 by I2. This will be equal to S over Q. So we can also say this equation equation, let's say this is equal to 1 and this one, let's say, is equal to 2. So as I1 over I2 is equal to R over P and I1 I2 is equal to S over Q, we can say that R over P is equal to S over Q. S over Q. Now from here, if we simplify this one, we can get PS will be equal to Q times R. So this is our final answer. This is what question was asking us. Our answer for this question is D. This is Wheatstone bridge circuit. If the reading on voltmeter is equal to 0, we can say Wheatstone bridge is balanced. So if this is true, Wheatstone bridge is balanced, then the ratio between this resistor and this resistor is always equal to the ratio between next two resistors, Q and S. Q over S. So then simply we can find our answer that PS will be equal to Q. Simply if you can identify Wheatstone bridge circuit and then if you can check is it balanced or not. If it is balanced, then simply you can use this ratio method and you can find your answer. This is a shortcut method. In today's lesson, we will talk about one great question from Cambridge ES Physics. This question is great because it will really test your understanding of DC circuits and components of circuits. This question is tricky and also confusing for many students at the beginning. So watch this video carefully to improve your conceptual understanding of DC circuits and components of DC circuits. For this question, it is given to us that the power supply has negligible internal resistance. It simply means that R is equal to 0. We are talking about ideal case. For ideal cases, we can also assume that the resistance of fuse is almost equal to 0, means is negligible, and the resistance of switch is also negligible. And also we are using connecting wires, and those wires are also ideal wires. These are ideal, mean the resistance is also equal to 0. Now the next thing, it is given to us a voltmeter is connected between negative terminal of battery and C1. Our voltmeter is connected here between these 2 points. Voltmeter is connected here. As you can see here, the wire is ideal wire. This wire is ideal, so it has no resistance. So it simply means that if I connect voltmeter between C1 and C2, if we connect voltmeter here between C1 and C2, these two voltmeter, they will give us the same reading. So in this case, V1 will be equal to V2 because this wire is ideal wire and there is no voltage loss. It is given to us with the circuit working correctly. The voltmeter reading is noted with the switch closed. Means our voltmeter is connected here between C1 and C2. We recorded the reading and that reading will be equal to 110 volts. This is equal to EMF of power supply. Now question is asking us which fault would result in the same 2 voltmeter readings. So it simply means that when there is a fault in the circuit, again we will see the reading, the potential difference across C1 and C2, that is equal to 110 volts. So we have four different types of faults and four options we have. We need to choose the right option. Let's look at option D. First of all, when there is a short circuit simply means that you can see here, you can imagine it's just a wire. If it is just a wire, it means there is no potential difference if you connect over voltmeter here. So in this case, for option D, this is option D, voltmeter reading will be equal to 0. So this is not our answer. If we go to part C, melted fuse, it means circuit is broken, or we can simply say this is open circuit. In this case, our circuit is broken. If you look at this point and this point, we can see the potential at these 2 points will be the same because there is no power supply between them. So we can simply say, in this case, if we attach voltmeter between C1 and C2, again reading will be equal to 0. So this is also not our option. It means it's not answer. If we go to B now, you can see for part B, it is given broken switch. The switch is broken. So again, if we take this point and this point, the potential here will be the same. And so we can simply say, in this case, if we attach voltmeter between C1 and C2, again reading will be equal to 0. So this is also not our answer. For A, it is given a break in the wire of the heater. So here means the wire of the heater. So you can see here, in this case, the potential at C1, that will be equal to 110 volts because this is connected with positive terminal, and C2 is connected with negative terminal. So we can say potential here will be 0 volts. In this case, you need to understand the potential difference. If we attach a voltmeter here, or we can say the reading on voltmeter, that will be equal to EMF of the battery. That will be equal to 110 volts. So this is our answer. This one is answer. This question is a little tricky one, but a great question to improve your conceptual understanding. In order to get maximum benefit from this video, you can do this question first of all by yourself and then come back and watch the video. For this question, a network of resistors is given to us and each resistor has a resistance equal to 1 ohm. So we can also say these resistors are identical resistors. What we need to find? We need to find the potential difference V across the input terminals. Or we can also say that if we attach a voltmeter here, for example, across these terminals, so we need to find the reading on this voltmeter. Let's try to understand some basic concepts first and then answer this question. Let's say the EMF of this battery is equal to 9 volts and this is resistor 1 and this is resistor 2. So if I ask you what is the potential at this point, you will simply say is equal to 9 volts, and potential at this point will be equal to 0 volt. And if I ask you what is potential at this point, you will also say simply it is equal to 9 volts because this wire is an ideal wire. There is no loss of energy, there is no loss of potential, and potential at this point will be equal to 0 volt because again this is the same wire and it is connected with negative terminal of the battery, so this is 0 volt. And potential at this point again will be equal to 9 volts and at this point will be equal to 0 volt. Now if we attach a voltmeter across this one, the reading on this voltmeter is equal to 9 volts, means the potential difference across this resistor is equal to 9 volts. And the same is true for the second resistor. The reading on this voltmeter also will be equal to 9. The second concept we need to understand, V is equal to I R, means Ohm's law is simply telling us if we have this resistor, let's say its resistance is equal to R and current passing through this resistor is equal to I, the potential difference across this resistor will be equal to. So these are two main concepts we need to understand, and then we can answer this question. Now as you can see here, current passing through this wire is equal to 1 amps. So we can also say current passing through this wire is also equal to 1 amps, and current passing through this resistor is also equal to 1 amps. Now if we attach a voltmeter at this point, and let's say we attach voltmeter at this point, and so what will be the reading on this voltmeter? So simply you can find out the potential difference across this one is equal to 1 volt, and potential difference across this one is equal to 1 volt. So the reading on this one will be equal to 2 volt. Now again, let me ask you another question. If we attach voltmeter at this point and at this point, what will be the reading on voltmeter? Now let's say here. So what will be the reading on this voltmeter? You will say it will be equal to 2 volts. The reason is that if I just move from here to here, between these 2 points, we just have an ideal wire. There's no loss of energy. There is no voltage drop. So this also will be equal to 2 volts. Now, as we now understand the potential difference across this resistor is equal to 2 volts and its resistance is equal to 1. So how much current is passing through this resistor? We will simply say this is equal to 2 amps. And this is according to Ohm's law. If this is 2, we need to find the value of I, and resistance is equal to 1. So simply I will be equal to 2 amps. So the current passing through this resistor is equal to 2 amps. The next step, what we need to understand is, let's label these points now. Let's say this is point A, this is point B, this is point C, this point is D, this is E, let's say this point is F. Now, as you can see here, the voltage across CD, we have found this is equal to 2 volts. As you can see, current passing through this resistor is 1 amp and current passing through this one is equal to 2 amps. How much current is entering into this junction? So according to KCL, we can simply say I entering has to be equal to I leaving. So it means current leaving is equal to 2 plus 1. So current entering is equal to 2 plus 1 is equal to 3 amps. So current at this point we can also say is equal to 3 amps. If we attach a voltmeter at point B and at point D, what will be the reading on that voltmeter? Let's say we attach voltmeter here. We attach voltmeter between these 2 points, between points B and between points D. So BD here, BD. So that will be equal to the voltage across BC plus the voltage across CD, So the voltage across BC we can find from here. This will be equal to 3 volts, and voltage across CD already we have 2. So the voltage across BD is equal to 5 volt. If I move this one from this point to this point now, let's say I move to this point now. So now what is the reading on this voltmeter now? So again, you will see the reading on this voltmeter will be equal to 5 volts, because between D and E there is an ideal wire. There is no voltage drop, there is no energy loss. So we can say the BD is also equal to the potential difference across BE. So we have found the potential difference across BE, that is equal to 5 volts. Means potential difference across this resistor is equal to 5 volts. So how much current is passing through this one? So we can simply find that is equal to 5 amps. Now look at this junction now. So how much current is leaving this junction? That is equal to 5 plus 3 amps. So means 8 amps. So how much current is entering? That has to be equal to 8 amps. 8 amps. So the next potential difference we need to find across point A and across point E. Let's say we try to attach voltmeter between A and E. So what will be the reading on this voltmeter? So that reading will be equal to the potential difference across this resistor plus the potential difference across this one. So the potential difference across this resistor will be equal to 8 volts and across this one is equal to 5. So we can say V8E will be equal to potential difference across AB plus the potential difference across BE. Across AB is equal to 8 and plus across BE that is equal to 5. So it means the potential difference across AE is equal to this, is equal to 13 volts. So it's 13 volts. Now my question for you is that, now if I connect this voltmeter across AF, so what is the reading on voltmeter? Means what is the potential difference across AF? Again you will say this potential difference is equal to AE because there is an ideal wire, there is no potential drop or there is no energy loss. So that is equal to 13 volts AF. And as you can see here, if I attach voltmeter here, for example, here now, so this is equal to 13 volts. How about across these input terminals? That is also equal to 13 volts. So we can say 13 volts. So our answer for this question is D.